Hello and welcome to a lesson on mathematical properties. So there are several mathematical properties that allow us to rewrite algebraic expressions without actually changing their meaning or their value. So the properties that we're going to look at today, again, they help us to rewrite algebraic expressions without changing the meaning or value of that expression. So when your expressions are changed or rewritten in this format, they may look different. Okay, they may look different. But again, they're going to have the same value. So if they look different, but they have the same value, then those two expressions, the one original and the rewritten, we call them equivalent forms of one another. They are said to be equivalent. Okay, so equivalent means that they may look different, but they're going to have the same value. So for example, let's say you bought a pizza and I bought a pizza, same size pizzas, okay? But I had my pizza cut into 8 slices, and oops, can't spell. And you had your pizza cut into 4 slices, same exact size pizza. You say that you ate 1 slice, and then you called me greedy because I ate 2 slices. But I'm trying to argue that, hey, we ate the same amount, which is actually, in fact, true, okay? So even though I ate 2 slices and you ate 1 because yours was cut into bigger slices, they are equivalent. So my 2 slices look different than your 1 slice because it's cut in half there, but we actually have the same amount of pizza, okay? So equivalent forms may look different, but they have the same value or the same meaning. So the first property we're going to talk about is one that is referenced quite a bit throughout math. Okay, so it's one that really you should try to imprint into your brain. The commutative property states that changing the order in which we add or multiply does not change the meaning or value of an expression. And this property does not apply to subtraction or division. It only applies to addition and multiplication. Okay? So the commutative property of addition says that we can change the order in which we add and still end up with the same answer. For example, if I had 5 plus 4, but then I changed the order and made it 4 plus 5. I mean, it looks different. In one case, the 5 is first, and the other, the 4 is first, but we haven't changed the meaning, right? Over here, 4 plus 5 is 9. Over here, 5 plus 4, or 5 plus 4, then 4 plus 5 still makes 9. So these look different because the order is changed, but they are actually equal. So we can change the order in which we add and still get the same value. And this will apply whether we have actual numbers or variables. So if I had x plus y, and I changed the order to y plus x, no matter what we substitute in for those variables, if it's the same x and y on both sides of the equation, then changing the order in which we add is not going to change the value. So those will have to be equal. And this applies to multiplication as well. So for the commutative property of multiplication, maybe instead of 4 plus 5, we have 4 or 5 times 4. So if I multiply 5 times 4 in that order, or I multiply 4 times 5 in this order, we're going to get 20 in either case. We can change the order in which we multiply and not change the value. And again, we could replace these with variables. If I had, let's say, a times b here, and I changed it to b times a here, it's not going to matter. No matter what I substitute in for those variables, it doesn't matter the order we multiply, we're going to get the same answer. Those will still have to be equal. Okay, now this does not apply to subtraction or division. So for instance, let's say I had 5 minus 4, that would get me 1. If I change the order to 4 minus 5, that would make a negative 1. So that is not commutative, okay? Not commutative subtraction. Division isn't either. So, for example, if you took 8 and divided it by 4, you would get 2. But if you took 4 and divided it by 8, you would get a half. Not the same thing. So that is not commutative as well, or either as well. Not commutative either. Changing the order in which we subtract or divide does not maintain the value of our operation. Okay, so subtraction or division does not commute. All right, so the associative property is another one that you'll see. You will not see this as commonly as you see or use the commutative property, but it's another good one to know. The associative property says that changing the grouping within again, a math problem that contains addition or multiplication does not change the meaning or value of that expression. Again, this is not going to apply to subtraction or division, but it will for addition and multiplication. So for example, with addition, let's say you had 1 and you were going to add in parentheses 4 plus 2. Okay, if I change the grouping, so instead of grouping the 4 and 2, let's say I change the grouping to the 1 and the 4, but it's all still being added, well, these two expressions are still going to be equal. So think about on this side, okay? If I have 1 plus 4 plus 2, inside of the parentheses, 4 plus 2 makes 6. So if I do in the parentheses to get 6, and then I add the 1 on the outside, I get 7. So if I change the grouping, that would tell me to do the 1 plus 4 first, which would give me 5. Well, then if I go and add the 2, well, I still get 7, okay? So it is not changed. Even though I change the grouping, I get the same answer. So we can replace these numbers with variables, and I know that substituting any variable back in isn't going to change the meaning. And so our associative property will hold for something like x plus y plus z and x plus y plus z. If I change the grouping for addition, still going to maintain the same value. Okay? And this again works for multiplication. So let's say I wanted to multiply 3 times 4 times 2. In this case, 3 times in the parentheses, 4 times 2 is 8. Okay, 3 times 8 is going to be 24. If I change the grouping, if I grouped it to 3 times 4 in the parentheses and then multiplied by 2, then inside the parentheses I have 12. If I then multiplied the 2, well, I would still get 24. Okay, changing the order in which we group, or not changing the order, sorry, changing the way in which we group does not change the value, so these are still equal. So with multiplication and variables, maybe x times, let's say, a times b is going to be equal to x times a times b. Okay, now notice in these examples here, the order hasn't changed. So it's 1, 4, 2, 1, 4, 2, xyz, xyz, 3, 4, 2, 3, 4, 2, xab, xab. We changed the order for the commutative property. We changed the parentheses, or the grouping, with our associative property. And again, this does not apply to subtraction or division. So let's say we had, geez, how would this look for subtraction? 1 minus 3 minus 1. So this would be 2. 1 minus 2 would be a negative 1. If I change the grouping, 1 minus 3 minus 1. 1 minus 3 in the parentheses would be a negative 2. And then I subtract the 1. Then I would get a negative 3 for my answer. Okay, these are definitely not equal, not the same thing. And not going to work for division either. So if you had, I don't know, let's say 1 divided by 4 divided by 4. Okay, in the parentheses, 4 divided by 4 is 1, and 1 divided by 1 is going to give me a 1 here. So if I change the grouping, 1 divided by 4 divided by 4, like this, not changing the order, but the grouping, well, this would be 1/4 divided by 4, and 1/4 divided by 4 is going to be 1/16. These are definitely not equal. So again, subtraction and division do not associate. Okay, there's no associative property for those two operations, just multiplication and addition. Okay, so there's one more property I wanted to talk about in this particular lesson. This is probably the most commonly used property in our algebra classes, and it's going to involve multiplication and addition or subtraction at the exact same time. So we have multiplication and addition or subtraction happening within one problem. And what this property basically says is whether you multiply and then add or subtract, or vice versa, you do the addition or subtraction, then multiply, that the result's going to be the same. Again, it's rewriting into equivalent forms. It just doesn't matter the order that we are doing these things, we're going to end up with the same result. The result is the same. So for example, let's say we're looking at a problem like 4 times 2 plus 5. So there's multiplication, that's what's implied with the parentheses here, but inside the parentheses we have addition. So according to this property, if, sorry, don't know why I changed to my highlighter, if we added first, so I'm going to add first, I'm going to go this way. let me organize this better, sorry. If I decided to add first, then inside of the parentheses I would have 7, right? So 2 plus 5 would make 7. And then I multiply, I'm going to end up with 28, okay? Well, let's say I decided to multiply first. If I multiply first, this is where we use that actual word distribute. If I multiply first, 4 would have to multiply by 2, and it would have to multiply by 5. Okay, it would have to multiply to each of the things inside of the parentheses. So if I multiply first, then I end up with 4 times 2 and 4 times 5. And after the multiply, then I add, I would end up with 8 and 20, which is still 28. So I get the same result either time. Now, when I'm looking at this expression that only contains numbers, it doesn't seem necessary to need the distributive property. But in fact we do, because there are sometimes in algebra where we don't have the option to add first. That might not be there, okay? So when there's variables involved, you may not have the option to add first, and then the distributive property is super helpful. Then we distribute, okay? So, for example, this inside the parentheses is telling us to add, and then there's a multiply by 5. It technically doesn't matter the order we do these things, but we can't actually add the x and the 7 because those aren't like terms, and we're going to talk more about that later. So in this case, the only thing we could do is the multiply first, is the distribute. So when we distribute, make sure we multiply to everything that's in the parentheses. So we distribute here, we distribute here. That means 5 has to be multiplied by x, which we could write as 5x, and 5 has to be multiplied by 7. Or we could say this is 5x plus 5 times 7 actually makes 35. Okay? And I don't know why I made so much space for all that. Same thing here. Okay, we don't have the option to add inside of the parentheses. None of those are like terms. I can't actually put those together. So I'm going to distribute. Multiply the 4 to the x, and to the y, and to the 3. So 4 times x added to 4 times y added to 4 times 3. And we could go one more step because we know 4 times 3. So we're going to say this is 4x plus 4y plus 12. Oops, I said plus, I wrote equals. Plus 12, okay? So those are technically 3 equivalent forms, okay? And then 3 equivalent forms on that one as well. Alright, sometimes it looks a little ugly. You might put a fraction in there, but this is the same thing. So I can't put any of these terms together. I'm going to distribute. So I'm going to multiply a half here, multiply a half here, and multiply a half here. And maybe you're one that doesn't like fractions. This is where a calculator might come in handy. So if you've already downloaded your app, awesome. If you have another calculator, that's totally fine. This is what the Desmos app looks like. Or if you go to www.desmos.com, this is what your calculator screen is going to look like. If you don't like multiplying fractions, then put it on your calculator. So we're going to use the divide button to put 1/2 in there. So a 1 divided by 2 gives me the half. Use the cursor to get out of the bottom of the fraction. And let's see, we're going to multiply by 2. Well, taking half of 2, multiplying by half is just cutting that number in half, so we end up with 1. So this is going to be half times 2x and a half times 4y and a half times 8z. Okay, well, cutting those numbers in half means I'm going to have really 1x and 2y and 4. Why do I keep doing that? I don't know why I'm putting the equals at the end there. I'm so sorry. And 4z. Okay, so again, 3 equivalent forms there. All right, last one. And again, I don't know why I gave so much space, but sometimes you're going to see the item to distribute or the factor to distribute at the end of the parentheses. It's a little strange, but it still means the same thing. So we can distribute the 6 in the same way we distributed the half in the last one. So I would multiply 6 by x and multiply 6 by 10. And that would leave me with 6x plus 60. So all 3 of those are equivalent forms. All 3 of them mean the same thing. And so, like if I gave you a problem like this one in your Canvas assignment, really this answer or this answer would be totally acceptable. Okay? And that is that. So hopefully you're okay with the commutative, associative, and distributive properties. You've got a handful of problems to work on in your practice assignment. If you find yourself needing some help, then just reach out. All right, guys, take care.